This video I'll demonstrate how to perform the Wilcoxon signed rank test. And this test is the non-parametric alternative to the paired samples or dependent samples t-test. And so in this case, we're measuring essentially the same group of people being measured twice on the same outcome. And this is typically what we would see in a kind of a pre-test, post-test design. So in this case, what we've done here is we've had people rank the importance of nutrition from very important to very unimportant. Then we had them go through a intervention, perhaps a nutrition education intervention of some kind, and then we had them re-rank the importance of nutrition, again, from that very important to very unimportant scale. So we've got here is two groups of people being measured twice on the same ordinal scale outcome. We could do this with skewed numeric data as well, but typically we see this done with ordinal scale data. So we've got two groups being measured pre-test, post-test. We want to see if there's a significant difference between the pre-test median and the post-test median values. So in order to do this, and again, the null hypothesis would be that there would be no difference from pre-test to post-test on the median score between the two groups. Now, very often, because we have these ranks and we don't have a wide range of possible ranks here, a lot of times the median might not appear to change very much, but what may change are enough people, their ranking changed, either it increased or it decreased, that would then indicate a significant difference, because what the formula is essentially doing is determining how many people went up or how many people went down in their ranking, and then looks for a pattern. So if there is a pattern demonstrating change in one direction or another, that will show significance, even though the median value for each group of scores might not change very much because we don't have a whole lot of possible choices with our rank. Then that can sometimes happen when we've got these more narrower Likert scale types of measurements that we're doing, which is in this case is an example of that. So in order to do this analysis, we're going to go to the analysis menu, the non-parametrics options, and you'll see the Wilcoxon signed rank test. So it does matter what order we enter these variables in. So since we're doing a pre-test, post-test design, there's a temporal order to this. So we want to make sure we enter variable 1 in as the first measurement we took, which in this case is nutrition rank. Then we click confirm. And then variable 2 would be the second measurement that we took, or the post-test, which in this case is nutrition rank. And then we click confirm. And then once we have those two entered in, we go ahead and click calculate. And we're going to look at the raw output first. And again, pretty bare bones. So what we're looking at here is a z-score for the change or the difference that we might be seeing. And we can see a z-score of minus 2.53, and this is associated with a p-value of less than 0.05. So this indicates that there was a statistically significant change in how the ranks were distributed from pre-test to post-test. And we can see here's an example of what I just mentioned, that even though the median didn't change very much, we're still seeing a change in the distribution of the particular ranks. And so that results in a significant difference or significant change. And we might be able to see that in the interpreted output here. Yeah, as we look at the two medians are essentially the same, but as we look at the whisker here along the top, that indicates the variability. In other words, the range of possible ranks that are occurring. We can see it's now a little narrower in the post-test value. So there were in the pre-test most likely a wider range of choices of ranks, and then at the post-test that became a little more narrow, a little more consistent. And so the median didn't change, but the variability within the responses changed, which resulted in this statistical significance. And so we can conclude that there is a significant change in how people rank the importance of nutrition after this nutritional intervention. And we can perform an effect size calculation to get a little bit more an idea of the clinical significance of this. So that would be, we're taking our z-score and then dividing that by the square root of the sample size, and that'll give us an indication of the effect size that we are working with. So hopefully you found this to be a useful video, and good luck using this technique in your own research.